The power of algorithms is that you don't have to reinvent the wheel each time. They're general solutions to problems. This holds as true for ancient algorithms as for modern ones. In 1998, in this garage in Menlo Park, California, an important piece of algorithmic history was made. Inside were two PhD students from Stanford University, Larry Page and Sergey Brin. Their aim was to come up with a search engine that could find things efficiently on the World Wide Web. Out of these humble beginnings, Google was born. But Google wouldn't be Google if it wasn't for the algorithm that Larry and Sergey created, called PageRank. PageRank was the algorithm at the heart of the first incarnation of the Google search engine. Now, technically, it's not a search algorithm, but a ranking algorithm. So when you type a query into a search engine, then there are literally millions of pages which will match that query. What PageRank does is to rank all of those pages such that the one at the top is the one that you're most likely to be interested in.
Larry and Sergey came up with the idea to do PageRank, to use it as a ranking signal to improve the quality of web search. I remember myself at the time, you used a web search engine like AltaVista. You would have to click the next page link a lot of times to find what you were looking for. PageRank was one of the reasons why Google was so much better than the existing search engines at the time.
The inner workings of PageRank are hidden from view on the World Wide Web. So to reveal how it does its job, we're going to use the PageRank algorithm to rank the players of a football team.
PageRank looks at two things. It looks at the incoming links to a web page, that is, the other pages that link to the page, and it looks at how important those pages are.
In our demonstration to show the cleverness of the PageRank algorithm, the players in the football team are the web pages, and the passes between them are the web links, the input for the algorithm. Generally speaking, the PageRank algorithm will give a higher rank to a website if it's got a lot of links coming from other websites. So in the case of football, if a player gets more passes from the rest of the team, then they'll be ranked higher. It's not quite that simple, because the PageRank algorithm actually gives more weight to a link from a website that itself has a high PageRank. So actually a pass from a popular player is worth more than a pass from a player who's hardly involved in the game at all. This is a visualization of the algorithm at work. The stats are the player's current ranking, the output of the algorithm. And every time there's a pass, these rankings are updated. When Google uses this algorithm, it only changes one thing: the input. In place of passes, it uses web links.
Note that the importance of a page depends on the importance of the pages that link to it. This means that you have to compute PageRank for all the pages at the same time. And you actually have to repeat the computation, because each time you'll update the importance of all the pages. And that in turn will influence the importance of the pages that those pages link to.
At the end of the match, the job of the algorithm is done. If we wanted to search for the key player in the team, this is PageRank's answer. Player 11 has the highest PageRank score. I think the PageRank algorithm is probably my favourite algorithm of all time. And it's amazing that it can be applied not just to the World Wide Web, but analysing a football match as well. But for me, it's the fact that there's a beautiful bit of mathematics at its heart that always seems to find the website I'm looking for.
Within Google, I think PageRank is seen as a very important part of Google's early development.
PageRank was the secret to why the search engine that Larry and Sergey built in the 1990s was so successful. Now Google handles over 3.5 billion searches every day. It's the world's most popular search engine. And the company is worth more than $450 billion.